when spring becomes horizontal. What is L? L is the natural length. L is the natural length of the spring, that one. What is the length OA? OA equal to phi L, no? It is given in the description. So is it spring elongated or compressed? Length of the spring is more than natural length. So spring is elongated. So how spring force will act? Spring force will act like this. Fine. So we don't know this distance OB, no? We don't know distance OB. Can we look at the geometry? From the geometry, phi L, 3L. So what can be this? This must be 4L. Now look at again when the spring becomes horizontal. What is the length of the spring? 4L. But what is the length of the, what is the natural length of the spring? Natural length of the spring is how much? It was L, no? So therefore, here spring elongated or compressed? No, here also it is elongated. Let it be kx2. Let's do one thing. So what was the question? What speed the ring will be moving here? This was the question that is asked. The weight, gravity also you have to consider. Now look at the, as the ring moves. So look at the spring force, constant or variable? It's a variable, no? Magnitude varies and also this theta varies. Trying to integrate will be in a big trouble. Can we take help of conservation of mechanical energy? Yes. What are the only forces doing work? The spring force and the weight. Both are conservative forces. So what about normal reaction? Normal reaction, how do it will act? It will act perpendicular to the rod and the work done by normal contact will be zero because at all positions it will act normal to the displacement of the ring. The work done by normal contact is zero. So what is the only forces doing work? The spring force and the gravity. Now I'll apply initial Ka plus Ua equal to Kb plus Ub. What is initial kinetic energy? Release from rest. Initial elastic potential energy of spring K1 x square by 2. Gravitational potential energy mg 3L is equal to kinetic energy mv square by 2 plus elastic potential energy of spring, then gravitational potential energy mg into 0. I think it's quite easy, no? So what is x1? Natural length is L. Now the length of the spring is OA, phi L. So what should be the elongation? Elongation should be OA minus L, no? Should be 4L. Huh? Now what about x2? X2 should be OB minus L. 4L minus L should be 3L. Substitute this. I think we'll get very easily the answer for V, no? Try to take the mathematical approach. So I'll find out the spring force at any position theta, then even the theta varying, then both magnitude F and theta, Kx and theta are varying. You should get a relationship between for X as a function of theta and trying to work out. Really, I think we'll be in big mess. So what is the advantage of using conservation of mechanical energy? You can minimize mathematics.